Hello children, welcome to PYQ-JEE Advanced session. Today I have brought a question from inorganic session to you, inorganic part of chemistry to you, and in JEE Advanced questions, only very few questions happen to be tough ones. Never all the questions are tough ones. Some of the questions will be very easy concept with, it may appear as a difficult one. I have brought such a question for you. In a glimpse, if you first look at this question, it may appear to be a complicated one, but this concept is a very simple concept question. Let us go through this question. In an experiment, m grams of a compound X, gas or liquid or solid, taken in a container is loaded in a balance as shown in the figure. You can see the figure here, and m gram, and in this place it is X here, and that X can be any of the substances chosen. In the presence of a magnetic field, the pan with X is either deflected upward as in figure 2. When you place some substance in the pan X, it may move upward as shown in figure 2 here. From this position, it has moved upward as shown in figure 2, or deflected downwards as in figure 3. It may go down as in figure 3. Depending on the compound X, identify the correct statements is the question. So, the concept must be very clear to you now. To begin with, in the absence of any external field, both were in same level. Now, in presence of a field, when an external field is applied, in figure 2, the pan X gets deflected upward, means it is being repelled by the external magnetic field. The substance kept in pan X is repelled by the external magnetic field, and in figure 3, it goes down. And when you say when it goes down, it means it is being attracted by the external magnetic field. From this much, the concept is very clear. The question is to distinguish the given compounds, discriminate them as diamagnetic substances and paramagnetic substances. We know diamagnetic substances are weakly repelled in an external magnetic field, and paramagnetic substances are attracted by an external magnetic field. So the whole question is, from the 4 substances given, you need to distinguish them as paramagnetic or diamagnetic. If paramagnetic substance is placed in X, then it will be attracted towards the field, and if diamagnetic substance is placed in X, it will be repelled as in figure 2. Let us go through the statements, and it is a question for more than one option correct. So let us see the first statement. If X is liquid water, deflection of the pan is upwards. Let us go to water. We know water H2O, oxygen bonded to 2 hydrogen atom, and all the electrons of oxygen as well as hydrogens remain paired. And diamagnetism is due to the absence of unpaired electrons, whereas paramagnetism is due to the presence of unpaired electron. In water, all the electrons remain paired. Therefore, water is a diamagnetic compound. Water is a diamagnetic compound. So, when placed in the pan X, it will be repelled. It should go upward. So, statement A is perfectly correct. If pan A has water, it will be moving upward due to the repulsion from the external magnetic field. Coming to K4FeCN6, in common nomenclature, what you call potassium ferrocyanide, K4FeCN6. Let us see its magnetic nature. We know FeCN6, iron is in +2 state. K4, 4 potassium ions outside the sphere. Sphere carries 4 minus, each cyanide -1. So, iron is in +2 state. And we know iron atomic number 26. The outermost configuration comes out to be 4s2, 3d6. And for ferrous, 4s2 electrons are lost and it is d6 configuration, 3d6. And d6 configuration in a strong ligand field. Whichever way you take it, whether you go by VB theory or crystal field theory, if you go by crystal field theory, I am just showing crystal field splitting part alone. So 3T2G and 2EG here, and D6 system in strong ligand field. 6 electrons, how they are filled? 1, 2, 3, 4, 5, 6. So all the electrons remain paired in potassium ferrocyanide. No unpaired electrons. All electrons remain paired. So this is also a diamagnetic complex. This is also a diamagnetic complex. So it should be repelled by an external magnetic field. Box option says if X is K4 FeCN6, deflection of the pan is upwards. Perfectly correct. If X is O2 gas, the deflection of the pan is downwards. Let us analyze O2 gas. And O2 gas normally we explain via MO theory. As per MO theory, O2's MO configuration is written as sigma 1s2. Total of 16 electrons, 8 from each oxygen. How they are filled in various MOs? Sigma 1s2, sigma star 1s2, sigma 2s2, sigma star 2s2. Then you have sigma 2pz2, pi 2px2, pi 2py2, pi star 2px1 and pi star 2py1. Pi star 2px and pi star 2py being a pair of degenerate MOs, they are singly filled before pairing up. So 16 electrons of O2 molecule are filled as sigma 1s2, sigma star 1s2, sigma 2s2, sigma star 2s2, sigma 2pz2, pi 2px2, pi star 2px1, pi star 2py1. There are 2 unpaired electrons, so definitely it is paramagnetic, which should be attracted by an external magnetic field. So pan should come down when O2 is placed in the pan. And C option says if X is O2 gas, deflection of the pan is downwards. Very true. And the last statement, if X is benzene, C6H6 liquid, deflection of pan is downwards. We know in benzene, all the electrons remain paired. All the carbons, 4 valence electrons are utilized and all are involved in bonding. Absolutely, carbons and hydrogens, everybody are involved in bonding, and no unpaired electron present on any of this. As a result, benzene is also a diamagnetic substance. So it should be repelled by an external magnetic field. If placed in X, it should go up. The statement says pan moves downwards, which is a wrong statement. So amongst the given one, the 3 correct statements are A, B and C. D is a wrong statement. Thank you, children. Thank you very much.